We're going to continue with chapter 16. So we've already talked about the center in terms of the mean, which we use expected value to represent our mean. But now we're going to talk about the spread. So because we're using a mean, we need to use our standard deviation, because remember that mean and standard deviation always go together. When we're dealing with random events, some will receive big payouts and others will receive nothing. In our card example, you either won $100 or you could lose $5. That's a pretty big range. This variation needs to be taken into effect. We do this by using the variance. To use the variance, we find the difference between the actual value and the mean. And again, in this case, the mean is expected value. To calculate variance, we first have to find the expected value. Once you find the expected value, you subtract it from the actual value. So you take each variable and subtract the expected value from it. Then you square that difference. After you square it, you multiply by the probability, and then you add everything together. So it's very similar to calculating the expected value, except you have to subtract the expected value and then square it before you multiply by the probability and add them together. Once you have the variance, we can find the standard deviation, because the standard deviation is just the square root of the variance. So once you have the variance, you take the square root, and that gives you the standard deviation. When calculating variance, we had to square our differences in order to keep them from canceling out. What this does is that it squares our units, and squared dollars aren't helpful. Therefore, we use the standard deviation by taking the square root, and that gets us back to our normal units, which is why we tend to use standard deviation over variance, because we're then being consistent with our units. The equations for the spread, variance often will be seen as var of x, and standing for variance, also is a lowercase sigma squared, and that is the sum of your variable minus the mean, or your expected value, squared times the probability of your variable. The standard deviation, which is SD of x, or given as just a plain lowercase sigma, is the square root of the variance. So you calculate this, take the square root to find the standard deviation. Looking at an example, we're going to use the AC example from the previous video, and we're going to find the variance and standard deviation to fix the AC. So from yesterday, we know that the expected value is 7250. So to find the variance, so the variance of x is going to be equal to our variable minus the expected outcome times the probability. Oh, and this has to be squared, plus our variable minus the expected outcome squared times the probability. So this ends up being negative 12.5 squared times 0.75 plus 127.5 squared times 0.25. So we end up with 156.25 times 0.75 plus 16,256.25 times 0.25, which ends up equaling 16,412.5. So that's my variance. Now again, this gives us dollars squared because we squared our dollars right here. So in order to find the standard deviation of x is going to be equal to the square root of 16,412.5, which ends up being $128.11. The standard deviation makes more sense because we're using dollars, where the variance is using squared dollars. Looking at another example, we want to consider a dice game. You get no points if you roll a 1, 2, or a 3. You get 5 points if you roll a 4 or a 5, and you get 50 points if you roll a 6. We want to find the expected value and the standard deviation for this situation. So in order to do this, it's going to be helpful to make a probability model. So that's what we're going to do. So I already have it set up where we're going to have our outcome in the first column, our variable goes in the middle column, and then the probability goes in the last column. So our outcome could be a 1, 2, or 3. We could have a 5 or a 4 or a 5, or we could have a 6. Now x, our variable, that is the number of points. So we get 0 points if we get a 1, 2, or 3, 5 points for a 4 or a 5, and 50 points for a 6. Now the probability, so it's a 6-sided die, So 1, 2, or 3 out of 6 is going to be 1/2. 4 or 5 would end up being 1/3, and then getting a 6 would just be 1/6. So to find our expected value, so E of x is going to be equal to the number of points times the probability we get those points, plus the number of points times the probability, plus the number of points times the probability. And this ends up equaling 10 points. So our expected value is 10. Because I may run out of room, I'm going to go ahead and write that up here, and then erase what I have down here. So now to find our variance, and even if you're being asked to find the standard deviation, we have to actually calculate the variance first. So in order to calculate the variance, we take our variable, subtract 10 and square it, and multiply it by the probability, plus our variable minus 10 squared times the probability, plus our variable minus our expected value squared times the probability. So then this ends up becoming 100 times 1/2 plus 25 times 1/3 plus 1600 times 1/6. When we add all of those up, we end up with 325. But again, this is dealing with squared points, and we don't want to have to use squared units. So in order to find the standard deviation, we take the square root of our variance. So the square root of 325 ends up being 18.03. So we have a standard deviation of 18.30 points. More about means and variances. Adding or subtracting a constant from the data will shift the mean, but it doesn't change the variance or standard deviation. So we first started learning about this concept all the way back in Unit 1 when we were dealing with the normal model. Those rules that we learned then apply now. So adding or subtracting will shift the mean, but it won't have any effect on your range or your measures of spread. So it won't affect our standard deviation or variance. The way that this would be written out is that your expected value of your variable x, if you add or subtract a constant to it, that's going to be equal to your expected value plus or minus your constant. For your variance, when you add or subtract a constant to your variable, it doesn't change your variance. It still stays the variance of x. Same thing would apply for your standard deviation, because if your variance isn't changing, your standard deviation isn't changing. For example, consider everybody in a company receiving a $5,000 increase in salary. So if the original mean was $30,000 and everybody got an increase, the mean is also going to shift. Everybody's shifting up. So now the mean would be $35,000. However, because the lowest person got a $5,000 increase and the highest person got a $5,000 increase, they still have the same spread between them. So your variance and standard deviation are not going to change. Continuing with this concept, if you multiply each value of a random variable by a constant, it multiplies the mean by that constant, and the variance is multiplied by the square of that constant. This one is a little trickier to kind of understand. The mean, if you multiply, then you multiply, but the variance, because when we're calculating the variance, we square our differences, that means then that everything has to be squared. So if you multiply each value, then you have to multiply the variance by the square. Again, this would be written out. So if we are dealing with our expected outcome, our expected value, and we have the constant times a variable, it just becomes that constant times our expected value. For the variance, if we are multiplying every value by a constant, to calculate the variance, you take that constant, square it, and then multiply it by the variance. Consider that everybody in the company is now getting a 10% increase in salary. Well, that means that if you were making $20,000, you're getting a $2,000 raise. But if you're making $100,000, you're getting a $10,000 raise. So in this case, not everybody is getting the exact same thing. You're going to multiply the mean salary by that 10%, but your spread is going to be greater, because the person making the lowest amount of money would have received a smaller increase than the person making the highest amount of money. So that's going to cause that spread to be a little bit greater, and it's going to change it. Let's look at an example. The time it takes to get and pay for seats at the ticket window of a baseball park is a random variable with a mean of 100 seconds and a standard deviation of 50 seconds. When you get there, you find only 2 people in front of you. We want to know, how long do you expect to wait for tickets? Now, when they tell us that we have a mean of 100 seconds, they're talking about our expected value. So each of the 2 people that are in front of us, we have to wait for them, and they will take an average of 100 seconds. This is going to be person 1 that we have to wait for, plus we have to wait for person 2. So the first person takes 100 seconds, plus the second person takes 100 seconds, for a total wait time of 200 seconds. In order to find the standard deviation, we actually can't add or subtract standard deviations together. We have to convert the standard deviation back to variance, add them, and then find the standard deviation again. If the standard deviation is 50, that means that the variance is 50 squared. So in order to find the standard deviation, our variance would end up equaling 50 squared plus 50 squared. And this equals 5,000. Then, because we have the variance, we then have to go back to standard deviation by taking the square root of the variance, which is 70.7 seconds. So when we are trying to calculate the standard deviation, we always have to go back to variance, perform the math, and then go back to standard deviation. So it's a little bit of extra work there. All right, we're going to look more at this tomorrow in class, but this is all that we have for tonight, so I will see you guys tomorrow.